Let's get started. So Michael Perry, the self-titled software mathematician, has been with Improving for over 10 years. He's going to be passing off his knowledge of math and services in this Microservices 101 L&L. So without further ado, Mr. Michael Perry.
Thank you very much, Cooper. Hi, welcome to Improving Talks. I'm Michael Perry, Director of Consulting based out of Dallas. So I lead teams of improvers to build software solutions for our clients, and some of those solutions include a pattern known as microservices. So I wanted to share what I've learned over the years about microservices, give you the what, the why, and the how about implementing a microservices solution. And I'll kind of finish it off with a little bit of the weird Michael Perry way of doing things. So hang on for that. So let's get started by defining our terms. So what are microservices? Well, I can tell you what they're not. They're not tiny services. And they're also not building blocks. Furthermore, you can't just uniformly say that a monolith is not as good as microservices. It's not monolith bad, microservice good. It's a bit more complicated than that. So how would you actually define a microservice? Well, you might just ask, what is a honeycomb cell? The problem is you never see just one in isolation. Instead, it's part of a system. So when the bees are building honeycomb, they don't just build one cell at a time and then stick them together. They build the whole system. And that's really where I'd like to start my working definition of microservices. So the working definition that we'll be using for today's talk is that microservices, plural, are a system of loosely integrated, autonomous, independently deployable software components. So focus on that word system, not a collection, but a system. They are intended to work together. So you might have heard the analogy that microservices are like building blocks. But the problem with that analogy is that with building blocks, you can put them together to form one structure, but then put them together in a completely different way and form a completely different structure. And that's just not true about microservices. Each one has a bespoke purpose, and they're intended to be put together in a specific way. Each one plays a particular role. And when they're put together, they form a system. So the next part of the definition here, that they are loosely integrated, this calls out to the fact that you integrate them via contracts. So you might have heard about contracts in the form of like an interface in a Java or C# application. So that's the contract that a class implements. Or you might have heard about contracts is in APIs. So these are all of the methods that your API implements. You can post and get to these endpoints. But yeah, I'm talking here about contracts that are a bit stronger than that. I'm talking about contracts about the behavior. The contract says that when you call this microservice, it will do a certain thing and it will respond in a certain way. So over and above just the technical, what parameters to pass and what shape to expect as a response. Now, negotiating and cataloging these contracts, that's a very important business function. Now, this isn't a technical function. There may be some technology that kind of feeds into it, but it is a business function. It is the responsibility of the business stakeholders of the organization to understand the contracts that are going on inside of the microservices and what those contracts are, and to make sure that they are being upheld. So that's the loosely integrated part. Now let's talk about autonomous. So an autonomous microservice is something that can deliver value without having to ask any other microservice for assistance. So if you were calling into a call center and then they had to take off their headset, put the customer on hold in order to talk to somebody else, then that service representative is not being autonomous. But a microservice should be able to autonomously deliver value without having to, in the moment, wait and get the help from another microservice. Now, this is in tension with the idea of being part of a system. So you think about, if it's part of a system, that means that it doesn't do the whole thing. It just does its own thing. And so it might need to talk to other microservices within the system. So how can something that's part of a system also be autonomous? This tension is really a big factor in that negotiation of those contracts. This is how you you decide what is the purpose, what is the scope of each microservice, how is it going to deliver value on its own without resorting to calling any other microservices. So we're going to talk a great deal about how to get that autonomy as you're doing that negotiation. But then moving on with the definition, we've got that these are independently deployable. Now, this is what separates microservices from any other modular architecture. In a modular system design, you've got several different modules that you might compile together and then deploy as a single unit. So think DLLs, think classes, those sorts of things. But in a microservices architecture, you really want each one of these modules, each one of these autonomous units, to be independently deployable. Why do you need them to be independently deployable? Schedules. Each microservice is in service of some business function. And that business function is owned by some subset of the organization. And so the people who run that part of the organization need to be able to set their own schedules and determine their own priorities. And so if you have everybody deploying on the same release train, then they're hamstrung. They can't work according to their own priorities and their own schedules. But by having microservices be independently deployable, then you can have each business unit running its own experiments. Let's see if we can put together a new marketing campaign. We might need some software to support that. So let's build that as a microservice and have a team dedicated to building that software and releasing it when they're ready to release it. So that necessarily means that these teams are cross-functional. They include all of the functions necessary in order to build, deploy, maintain, operate that microservice. So that's not just developers, that's also testers, that's also ops. So everybody that's necessary in order to make that microservice work. Now, these folks that are all embedded on this cross-functional team, we want them to truly be embedded on the team. They're part of that team, not matrixed, not beholden to somebody else's schedule, and you might get some of their time. So that is going to play a key role in deciding how far we want to go down the microservices path. But if you've got a matrixed organization, then you're still going to be competing for people's time, and then priorities get conflated with one another. This is the only way to have something that's independent, is to truly have independent teams. So that's our working definition. And so now that we've got kind of an idea of what we're talking about when we talk about microservices, let's take a look at why. Why would you want to adopt a microservices strategy? Now, if you really think about what you're buying into, you'll have to consider the cost. So the cost of microservices, it really comes down to those independent teams. So since you've got team members that are dedicated to each microservice, that means that you're going to have some redundancy. That means that you're going to have a database professional on one microservices team and a different person altogether who's also a database professional on a different microservices team. And so that means that you're hiring more DBAs than you might otherwise in a matrixed organization. But that's the cost of getting these independently deployable units. You'll also have independent infrastructure. So as you deploy these units, you'll want to be able to independently scale them based on the load that they receive. And so if everybody is running in the same Kubernetes cluster, then you might not be able to to scale things appropriately. But yeah, if you're able to kind of separate that and have those microservices talk to each other over infrastructure, but still maintain their own separate infrastructure components, then you're going to get the best value out of it. But that comes with cost. And that basically just boils down to redundancy. You're going to have more people than you originally planned. You're going to have several people who can do the same jobs. You're going to have more more resources in terms of machines and data storage than you originally intended. But if you don't have these things redundant, then that means that you force different microservices, different projects to wait in line in order to get to those people, in order to get to those resources. So microservices are not cheap. Let's also take a look at the complexity. Now, modular software components within the same process can communicate using in-memory mechanisms. You can just call a function, you can pass parameters, you can even share data, and things work out just fine. But in microservices architecture, then you're communicating over an unreliable network. So you've got these independently deployable units. They need to be able to send messages to one another. And sometimes message communication fails. You have to serialize those things and send them to others out of process. That serialization means that you can't just simply take a regular C# or Java data structure and pass a pointer. You have to actually convert that into some kind of message that's going to live now outside of that process, even across different versions. And so there's some extra complexity to deal with those serialized requests. And the unreliable networks mean that where you usually would call a function and then it would either succeed or throw an exception, now it's possible for you to call a function and then there's just not be anything there to pick it up. So you have to time out, you have to retry. That might introduce duplication, that might introduce messages arriving out of order. All of these things add to the complexity of microservices. So microservices are not simple. And given all that, why would you bother? Why would you want to do this thing? Seems like a crazy thing to take on. So one of the big benefits is business agility. So if your organization experiments and it wants to disrupt the market, then you need a way to run those experiments and have the software to support those experiments. You need to allow things to fail without taking down the entire organization. You need to be able to roll out an experiment knowing that it might not be 100% solid code that you would want to bring into your main product line. But run that experiment, gather some data, and then upgrade it quickly. You get that business agility if you can independently deploy your components. This also gives you the flexibility to try out new infrastructure components. So we're a .NET shop. Let's try some Java. Hey, let's put some JavaScript in there. Let's try this new this new data store, these are different ways that you can flex the technology by using different ideas and different patterns in different microservices to try things out. You don't have to adopt one platform and upgrade everything all at once. And it gives those teams the autonomy to make the decisions that they need to make, both in the way that that they run the business, but also in the technology that they choose. So this, I think, is the most important reason for any organization to choose a microservices strategy. But there is another reason that you might hear people talk about, and that's scale. So if your organization serves tens of millions of customers, then you might find that having them all contact your system all at the same time is starting to put some load on the front end. So you've got your web servers, your APIs that are taking on all that load. But meanwhile, maybe the database is just kind of humming along, not doing very much, in terms of supporting those requests. So microservices give you a way to independently scale those things. So if you're processing several different transactions all simultaneously, then it might make sense to have a microservice dedicated to that transaction processing and use some different infrastructure that's specifically intended for that purpose in that microservice. So the rest of your system might be using a SQL database or NoSQL, whereas the part of the system that's doing this transaction processing might be using something else. And then there's, of course, the size of the data. So if you're even if you're not receiving a lot of requests from a lot of customers, if they are dealing with large units of data, then you might need to scale in order to manage those large data objects. So if you're Netflix or Google or Facebook, then you might want to take a look at microservices for scale. In fact, all of those organizations have adopted a microservices-oriented architecture specifically for scale. But even if you do have that level of scale, it might not always be the best thing for you. Just recently, Amazon posted that they have rewritten their Prime Video monitoring service to go from a microservices architecture back to a monolithic architecture, and in so doing, reduce their costs. So wait a minute, didn't you say that microservices give us this scale? Well, it's complicated, and different workloads require different things. This particular workload required a lot of memory, and so bringing up a microservice and having it allocate a lot of memory in order to process just a small number of transactions, that was causing a lot of churn, a lot of cost. This was a workload that was better served by a monolith. So there is no silver bullet. You just need to consider the work that you're trying to do and what advantages you're trying to find. So if I've said anything so far that hey, maybe you've got some questions about, go ahead and send your questions in the Q&A. Cooper, do we have any questions so far?
Yeah, I have one. What advice or what strategy would you provide for going from a monolithic to microservice architecture?
Yeah, that is an excellent question. I'll cover that in a little bit more detail later. The answer, in my opinion, is to start with the database. We'll find that the database is often the most difficult thing to decouple when going from a monolith to a microservice. And so, coming up in just a little bit, I'll talk specifically about strategies on decomposing your database. Excellent, thank you. So now that you've evaluated whether your organization needs to adopt a microservices strategy, let's talk about how. You're going to find a lot of great advice in this book, Pro Microservices in .NET 6. So these folks, Sean Weitzel, Rob Richardson, and Matthew Groves, these are incredibly knowledgeable and incredibly nice people. So you can find them online, and you can read about their advice in this book. It walks you through the process of setting up a microservices strategy. It starts with testing, and then takes you through messaging, decentralizing your data, and finally operations. So how do you deploy and monitor these things? So let's go on that journey right now, starting with domain-driven design. So when you apply the domain-driven design principles to a problem domain, the first thing that you want to do is to identify kind of the nouns and the verbs within the domain itself. So we might be talking about a domain where customers can place orders. The customers will receive an invoice for an order. And the order lines are each for a particular product. So these are conversations that you can start with your product owners and your domain experts in order to figure out, what are the nouns, what are the verbs, what are the important rules. As you do so, you will identify what are called aggregate roots. These are the top level of a tree, an aggregate of like an order contains a whole bunch of order lines. An invoice contains invoice lines. So defining those aggregate roots helps you to identify where the possible boundaries could occur. Now, one problem that I see with when people try to adopt a microservices strategy is they say, oh, I've got 4 aggregate roots, therefore I've got 4 microservices. And that might not be the best way to go. You might find that it makes a lot more sense to group a couple of aggregate roots together. So in this example, the sales microservice is responsible for the customers and the orders because they're both related to that sales process. We'll manage products in the catalog microservice, and we'll manage invoices in the accounting microservice. You can imagine other things happening in accounting. You've got the payments, you've got the ledgers, accounts, of course. Those are all top-level objects, aggregate roots inside of the accounting microservice. Now, in domain-driven design, we're not really talking microservices necessarily. These are your bounded contexts. So a bounded context in domain-driven design is a way that you can describe a group of things that kind of work together. You can have a meeting about the things in a bounded context, and for the most part, ignore the things that are in the other bounded contexts. So a bounded context, I think, is a good start for maybe having a microservices boundary. But even then, you might find a microservice that includes 2 or more bounded contexts. So it informs the decision, but it doesn't make the decision for you. Now, domain-driven design, it's been a great pattern that people have used for all sorts of different applications, not just for microservices. So I would actually recommend, do that domain-driven design analysis and then put together a modular monolith. That's probably the best place to start. So you start with a simple but modular design, and you have the code recognize the fact that sales is a different module than accounting, but they're still deployed as one unit. The reason for this is that microservices are intended to be built as a system, not as just independent components that you can say, okay, I've completely built the sales microservice, I've deployed that, and now it doesn't talk to anybody, nobody talks to it, but I'll build the next one and I'll snap that in. The problem is going back to those contracts. How do you know that the sales service has the right behavior? How do you know that that the microservices that it needs to connect to will implement the correct contracts? You can reason about those things and whiteboard on them and have meetings about them, but until you've written code, you haven't validated those contracts. And the easiest way to validate contracts is to just write them as just regular old interfaces in C# or in Java or in TypeScript and code against them. Let the code work out what those contracts truly are. And then you've got a really good idea of what those contracts will be and how the messages will flow from there. So if you were to follow this approach, then you will inevitably find yourself decomposing. You will find that you've got something that's one project, one deployable unit, and you need to decompose it into multiples. You will never actually finish that process of decomposing your code, because as you build, you'll discover that now this microservice is taking on too much responsibility. It needs to be decomposed. So this is going to be a routine practice that you're going to have to get good at. So let's just start there from the beginning. The best place to start, as I said before, is to start with the database. Now, there's a couple of reasons for this. One, it's the most difficult place to start. It's the most difficult thing to tackle, which means let's go ahead and take that hit up front. Let's take that risk. But then the second thing is that once you have a decomposed database, you can still have a single process that is accessing that decomposed database. And then the rest of the contracts that are happening within the microservices can be simulated within that single process. So decompose from the database up. I have in my past taken the other approach and lived to regret it, where I decomposed the application into microservices, but then had them all talk to the same database. Getting from there to a completely independently deployable set of microservices was quite tricky. So you're looking at a database, you see a whole bunch of these tables, and you say, okay, these tables over here, those belong to the sales microservice. Then we've got product over there, that's the catalog, and down here we've got invoice and invoice lines, those are related to accounting. So you can see where the microservice boundaries will eventually be. So that means that we need to subdivide these tables. But when you draw that circle, inevitably, you're going to cut right across one of those lines, one of those foreign key relationships. And so that means that in order to decompose these, you're going to have to break those relationships. But now, wait a minute, this invoice needs an order ID. This invoice line needs a product ID. What am I going to do to get those IDs? You're going to need to duplicate or replicate that data in that subsystem. So let's actually make a copy of the product table and have that available for the sales process. Let's have another copy of the product table that's available for the accounting module. So we've duplicated these tables. You end up with redundancy. You end up with have 3 tables where I used to have 1. That seems wasteful. I'm breaking the dry principle. I'm repeating myself. All this data all over the place. Well, that's the cost of being independently deployable. If you want to be independent, that means you have to have your own separate copy of the data. So that is the cost that we'll have to take. And now we need to also add some complexity in order to make sure that these replicas stay up to date. So now that we can put our circles around these groups of tables that only have foreign key relationships within themselves, now let's talk about how do we synchronize this data from one to the next. The most reliable way to do that is with asynchronous messaging. So now we've broken those foreign key relationships. The smaller groups of tables don't know about one another. We can now completely encapsulate those tables behind the module. So we've got the sales module, the product module, the accounting module. and they are no longer talking to each other in terms of these foreign keys, these primary key relationships. Instead, now they can talk to each other in terms of business concepts. So it's not a product ID anymore. It's SKU. It's not a sales order ID anymore. It's an order number, something that the user could see from the outside. So now these are going to be communicating with one another using these concepts, and they're going to do so over a bus. Now, when we first start out as a modular monolith, this bus is going to be something that's just in memory. But as we evolve to a microservices architecture, this bus will include things like RabbitMQ. This will perhaps include things like Kafka. Whatever infrastructure makes sense for the type of system that you're building. And now the goal of doing this was to synchronize those tables, right? So you've inserted something into the order table in the sales module, soon to be the sales microservice. So I could say order inserted. That's a very database-y way of saying it. Let's go ahead and raise that up to the level of talking about the business. Let's talk about the order placed domain event. So the sales module, soon to be microservice, will publish that order placed event. It will have information in there like the SKUs of the products that were ordered. It will have the order number that the user could see. It doesn't have any database IDs in it, though. It's just domain level concepts. Puts that on the bus, and then those that are interested in it will take that and process that in their own database. So when we're starting out, the purpose for doing this is so that an insert into one sales or one order table becomes an insert into another order table. So go ahead and think about it in those terms, but then just write the contract in business terms. And then it will eventually evolve into domain contracts that work well for microservices. So this is a technique that has worked very well for a number of organizations. You'll see people talk about this technique. Do we have any questions on how we decompose a monolithic or a modular monolith into microservices?
Not necessarily any questions on how, but a question on how and why. If you were to sell this to the business, I know you touched on the components of microservices, but what would be your strongest selling point for why you should even attempt this in the first place?
Yeah, I would not start with the scale argument. I know that a lot of folks do. In my experience, very few organizations actually need that kind of scale, and if they do need that kind of scale, they can get it with some much simpler architectural components. So yeah, if you want to achieve scale, you're using stream processing, do that before you invest in microservices. But when I do see that people are running an experimental type of organization, and they really want to be able to quickly deploy and try new things, then that's a really good way to introduce microservices. So a lot of times, an organization will bring in a consulting company like Improving and say that, all right, in 4 months, in 6 months, we've got this this big conference that we're going to be going to. When we go there, we want to be able to deploy this product, and we want people to try it out. So we've got a very short time frame, and we want to get something that people can see and start to use. So even if they are their entire organization runs off of one single monolithic application, that is a good way for us to say, okay, let's build this off to the side. It's not going to follow all of the the governance and the patterns that you have in place for your main product, but it's also not going to interfere with the main product. we'll build this off to the side, and we will insert just enough code into the main product that we can integrate. We can publish and subscribe messages, and that's it. And then that way we can run experiments. We can deploy something quickly, and get this microservice up and ready. It gives you a lot of visibility into the process as you're building the microservice. That with a with a more monolithic approach, you might have to wait longer before you can see some value. So that's, I think, one of the most important reasons for adopting this pattern in the first place.
Appreciate it.
All right. So far I've told you things that while maybe some of my opinions are a little bit different, for the most part, you'll see others that that share these similar opinions. But now I'd like to introduce myself to those that haven't met me before. Hi, I'm Michael. I am obsessed with immutability, and I even wrote this book about it. I like to apply this idea of immutability to how I analyze and sometimes even build microservices. So let's analyze the system from the immutable side of things and see what that tells us about how we're going to design and build our microservices. So let's start with a definition of immutability. Immutability is the deliberate and disciplined decision not to change data. So it's not even saying you can't change data. You just really shouldn't. It's something that if you make this decision and you follow the discipline to not change data, you get a lot of benefits. So it does lead to a different way of thinking, however. So this does mean that you're going to have to have a lot of organizational will. And so this actually might be a good way to run that experiment. Let's try immutability in this one scoped isolated microservice and see if this is going to work out. Ordinarily, we think about things in terms of objects that have properties that can change. So you've got these tables that you could insert, you can update, maybe you can even delete. I wouldn't recommend delete in any case, and most of the time you would just have a flag that says deleted, but that's still an update to that flag. So you're still mutating the data. And that's how we've come to think about software these days. But if you think about it, that's not the way that business has always been done. Usually, before the age of the database, we would just do business by exchanging documents. And these documents are immutable. Once you write a document, sign your name to the bottom of it, that document doesn't change. So excuse me, the status of your order doesn't go from payment pending to paid. It's just that you've got the order, and then later on you've got the payment. So let's see if we can return to a way of thinking about business transactions as documents. So the way that I like to do this is, let's think about the most important decision that somebody makes within our business. And oftentimes it's not a decision that the organization makes, it's the decision that some other stakeholder makes, like the customer purchasing a product. So let's go ahead and write that up on the whiteboard, draw a circle around it. Everybody's looking at that whiteboard and say, yep, that's pretty important. Let's start there. Now you think about, what are the decisions that had to have happened before this one? Well, before a customer can purchase a product, we need to determine its price. So that's the decision that our marketing team makes. So let's write that up there. We're going to price a product. Well, before we can price a product, we need to have listed the product in a catalog. Oh, then that means that, okay, we actually need to have put together that catalog. Oh yeah, and before that, we needed to have actually founded the company. So this is a chain of events that the ones at the top had to have occurred before the ones at the bottom. And you can see that I've got these arrows that are pointing upward. So that's not a mistake. Even though time proceeds down the page, the arrow indicates that the purchase knows about the price. The price knows about the product. The product knows that it's in a catalog. And so you've got this knowledge pointing back in time. So you might look at this and say, okay, yeah, we've got this history of all of the events that have occurred, but it doesn't necessarily have to be linear. You can find that that other events might occur in parallel. So while as a company, we're off creating a product and filling it, creating a catalog, filling it with products, allocating prices. Meanwhile, a customer is coming to us and signing up, creating an account, establishing that relationship. And the customer has to have that relationship before they can purchase a product. So you've got these parallel histories that could happen. The history branches and converges. And this forms a graph. This is a directed acyclic graph for those that that love the computer science like I do. And that means that when you do something like this, you can never create a cycle. And that comes from the fact that the things that happen at the top of the graph happened in the past. So you can't create a time-like loop to go back to the past and have that past decision based on some future decision. Decisions are always based on something that happened before. So I call this thing, for that reason, a historical model. This captures the history of the decisions that would occurred in order for somebody to purchase a product. Now that we've got a model of the things that happened before purchasing a product, let's take a look at what happens after. After the order, we will create a pick list. And then now that we've got that pick list, we'll ship it and we'll have that shipment object, that shipment fact. So that will have something like our tracking number. And then we will get a confirmation of receipt by the customer. And so these are things that that will happen after purchasing a product. But again, it doesn't have to be strictly linear. There could be other things that happen in parallel. Like, for example, after you purchase a product, you'll create an invoice, send that to the customer, and then at some point later, they will send you a payment. So you've got these other facts that are occurring at other times within the process. A historical model really does a great job of illustrating the practices that your organization undergoes. So maybe your organization allows drop shipping. So if you don't have something in stock, then you'll issue a dropship order. The other vendor will deliver it directly to the customer, and you'll receive a receipt of that dropship delivery. And then what happens if you need to issue a refund? Do you, as an organization, decide that you can only issue a refund after a return? That's the decision that you have to make as an organization, and then you capture that in your historical model. So the model for your sales and delivery process is going to look different from this one. Go ahead and capture that so that everybody can look at that model and understand the consequences of those decisions. So it's a great way to communicate those acceptance criteria, to have those conversations about use cases. Now, how does this relate to microservices? Well, if you were to carve up this model according to who makes what decision, you'll find patterns emerge. It looks like this. So at the top, you've got the executive decisions. Then marketing is making decisions about pricing and product listings. Meanwhile, the customer is making a decision to sign up for the site to place the order. Shipping is making all of those logistical decisions, and accounting is making the decisions about invoices and payments and refunds. So you carve up the historical model according to who's making those decisions, and these give you regions within the model. These regions are your microservices? This is how I like to begin that conversation. Now, you'll notice these are not particularly micro. It's not that we've got a microservice for each individual decision that can be made. In fact, we might have lots of decisions that are happening inside of a single microservice. The micro isn't the important part of it. It's that single responsibility that the microservice is in support of a specific business function. And then you now have the ability to innovate on that business function and independently deploy that unit. Now, if you take a look at these names up here, you might notice that you probably have somebody in the C-suite dedicated to the success of each of these business functions. That's not a mistake. You organized your organization that way because that was the most effective way to create the organization. So why wouldn't you organize your software the same way? In fact, there's a name for this. We call this Conway's Law. Any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. So if you've got a member of the C-suite that is dedicated to each of these business functions, they each have their own budget, they have their own headcount, they have their own charter, they have their own autonomy to make sure that their part of the business functions well. So give them a development team, give them a QA team, give them operations, give them a way to deploy the software that they need to support their business operation. Now, the next thing that you're going to want to do is to take this historical model and start to turn it into an actual implementation of microservices. Fortunately, there's some math that can help you out with that. The first bit is transitive closure. It's a fancy way of saying, draw a cone. Take all of the arrows that come up from a given decision, and everything that's included in that cone is part of the transitive closure. The transitive closure of an immutable fact is itself immutable. You can't add anything more to the graph because those things happened before. So now you can take the things that are in that transitive closure, exclude the things that are not, and turn that into a message. That's your contract. That's the thing that you send from one microservice to the other. And then when you take a transitive closure of some historical facts, you can insert them into an immutable database. Each microservice will have its own replica of this immutable database that is just the part that they need. If you were to send messages from one to the other, they would each merge those immutable facts into their understanding. And then even though each one has its own separate subset, taken together, they have a consistent vision of what your organization looks like. So that is the way that I like to use immutability to derive a microservices implementation. So, not all organizations are ready to take on the task of immutability and all of the extra learning that is required for the developers to get on board with that discipline and that approach. But if you do, I think you'll find some really solid benefits. So if you want to learn a little bit more about immutable architectures and how we can use them to build microservices, go ahead and subscribe to the .NET Rocks podcast, because coming up in just over a week, you will have an episode show up where Carl and Richard talk to me about immutable architectures. You can also check out the book at immutablearchitecture.com. And of course, reach out to me directly at michael.perry@improving.com. And I will be glad to come talk with your organization about how you can build microservices. And yeah, thank you so very much. This has been a blast. Any last questions?
I like what you said about immutability and the sections of the process that aren't really touched by other business processes. Something I hadn't heard before.
Yeah, that's that's not an idea that's gotten a lot of traction yet, but I'm still working on it.
Yeah, we actually two other questions from Adam Hill.
Mhm.
Are there any OSS databases out there that would be good for immutable architectures?
Adam's a good friend of mine. This is a nice softball. Yes, in fact, there is. Yeah, it's called Janaga, and you can find out more information at janaga.com. So this is an infrastructure that I'm building first for TypeScript that will help people to build web applications and mobile applications using immutable patterns. And
then from Kyle Den, it's kind of similar nature. What immutable databases are out there?
Yeah, yeah. So in addition to Janaga, as I mentioned, you've it's not a terribly popular pattern quite yet, but yeah, you will find some others. There's one called Gun that I had looked at. I'm not sure if it's still being maintained, but yeah, other things like oh goodness, I see the logo is a man with a top knot. It's not coming to mind, but yeah, another immutable architecture that you might want to follow is event sourcing, and there are systems that are specifically designed for event sourced applications. So yeah, for those you would look at things like Martin. And then if you use Kafka, most people use Kafka as an infrastructure component, but Kafka is really an immutable database. So so that's another alternative for you.
Awesome. And we have one last question from Reza. What do you think about vendor products like Microsoft for building microservices?
Yeah, I find that a lot of the vendor products, they tackle kind of the low level technical problems, but they leave a lot of the more difficult business problems up to you. So so it's very tempting to adopt something and say, okay, that's our solution, and then not apply it correctly. So you really need a full end-to-end strategy. And then at the end of that strategy, if you decide that you're going to adopt a vendor product, then that's a valid decision. Of course, beware of vendor lockout. So if you use a SQL database, if you use message queues, you can and you use Kubernetes, you can take your microservices architecture and move it from cloud to cloud, and not be locked into any particular vendor. But if you go with a platform as a service offering, it might speed you up, but it'll also lock you in.
Great, thank you. Just for everybody's information, the next speaker is Harold Poulter, getting started with GitHub Actions. But Michael, just want to thank you for taking the time to educate us on microservices. I learned a lot, and I thought I knew something.
Excellent. Yeah, thank you so much, Cooper.
Not a problem. Well, you all have a wonderful Wednesday, and we'll see you next time. Michael, if you want to do a quick, I usually do a post session just to kind of discuss how it went, any questions, anything that you want to discuss.
Yeah, this was a lot of fun.
Cool. Awesome. Yeah, I really did. I mean, I've worked, the previous client I worked with were very particular on microservices. It was all microservice based, and the current one is entirely monolithic. Does make me miss that microservice architecture, but
Mhm.
we had our own problems where we had one team dedicated to all the microservices. So there wasn't that real separation. It was, same thing for one team everywhere.
Yeah. Yeah. So you end up with all the pain of microservices and very little of the benefit.
Yeah,
Like,
that's exactly
this
it.
one team, we'd have been able to build one monolith and deploy it all at once because we're deploying the whole thing at once anyway. Just by doing this, this Kubernetes, kubectl apply. And it's like all microservices. It's like, okay, yeah, that might not be exactly what you're after.
Yeah, that's probably why I enjoyed it, but I don't have like the most let's say optimistic take on them, just because that was my only exposure. But I would love to move away from monolithic, because monolithic has far more problems to me than microservice implementation, but ours is a mess. It's just massive. So it to move on to microservices is a hard sell.
Yeah, it is.
Cool. Well, I appreciate you once again taking the time, and I guess I'll see you on the next one.
Indeed. Yeah. Thanks, Cooper.
Awesome. Not a problem. Take care.